the three-dimensional Cartesian plane for three-dimensional geometry, which is used in a wide range of applications including game designing. The lines and angles they form with the axis can be described using vectors. How should we describe a line passing through the origin making an angle with different axes? We define them in terms of cosine ratios of the line. It is vital to discuss the significance of the line that exists in three-dimensional space while dealing with three-dimensional geometry. This video helps us to navigate through the core concepts of 3D geometry. Now suppose this is a 3D system with x, y and z axis and consider a vector OP. Now there are certain angles that OP makes with these axes. Let alpha be the angle with x-axis, beta be the angle with y-axis and gamma be the angle it makes with the z-axis. These angles are made in a positive direction. Then these alpha, beta and gamma are known to be the direction angles. Thus, direction angle is defined as the angle made by the vector with the reference axis. Here the angles are alpha, beta and gamma, which makes with the x-axis, y-axis and z-axis respectively. Now, if we reverse the vector, what happens? The angles will also change, like pi minus alpha, pi minus beta, pi minus gamma. Now, if we take the cosine of these angles, it will give direction cosines. That means cos alpha, cos beta, cos gamma are known to be the direction cosines of a given vector. We can call it as DC of that vector. Now, cos alpha is represented by the letter L. Cos beta is represented by letter M and cos gamma is represented by using letter N. Suppose if we reverse the vector, the signs of direction cosines will also be reversed. Why? Because now the angles under consideration are pi minus alpha, pi minus beta and pi minus gamma. Now we have to discuss about direction ratios. What are they? These are any three numbers which are denoted as A, B, C which satisfy a certain proportionality relation. And what is that proportionality relation? Which is L by A should be the same as M by B. It also should be the same as N by C. So, any of these numbers which are satisfying this relation qualifies to be the direction ratios. Now, let us discuss an important concept, that is, what are direction cosines and direction ratios of a line? A line is something which extends to both ends. That means it is a combination of two vectors in the opposite direction. Then here also ABC as the direction ratios of the line and we have L, M, N as the direction cosines of the line. Then L by A is equal to M by B is equal to N by C. Say it's a constant K. Therefore, L is equal to AK, M is equal to BK and N is equal to CK. Now, but L square plus M square plus N square is equal to 1. Substituting here, we get K square into A square plus B square plus C square is equal to 1. Or K can be written as plus or minus 1 by square root of A square plus B square plus C square. Hence, we can say that the direction cosines of the line are L is equal to plus or minus A by square root of A square plus B square plus C square. M is equal to plus or minus B by root of A square plus B square plus C square. And similarly, we get N as plus or minus C by root of A square plus B square plus C square. Now, next we have to see the relation between direction cosines of a line. So, for that, consider a line RS with the direction cosines L, M and N. Now draw a line parallel to RS and passing through the origin, that is OP. Now take any point P with coordinates X, Y and Z on this line. Now from P, draw PA on the x-axis. Now we have to go for the derivation part. Let OP equal to R, then cos alpha is equal to OA by OP, which is equal to X by R. But what is cos alpha? Cos alpha is nothing but L. Therefore, we can write X is equal to L into R from this relation. Similarly, we get Y is equal to MR and Z is equal to NR. Now, if you're taking the square and adding these X, Y and Z, we get X square plus Y square plus Z square is equal to R square into L square plus M square plus N square. But X square plus Y square plus Z square is equal to R square. So putting this R square instead of X square plus Y square plus Z square, and we get L square plus M square plus N square is equal to 1. And this is the relation between direction cosines of a line, where L, M, N are called the direction cosines. Now, let us see how to find the direction cosines of a line passing through 2 points. Since only one line passes through 2 given points, we can suppose the end points of a line as P, X1, Y1, Z1 and Q as X2, Y2, Z2. Let L, M, N be the direction cosines of the line PQ, and the line makes angle alpha, beta and gamma with the X, Y and Z axis respectively. Now, if we draw a perpendicular from point P and Q to the XY plane, it will meet at R and S. Then again, if we draw a perpendicular from P to QS, it will meet at the point N. So, constructing here a right angle triangle. Let's have a close look. So, in that triangle PNQ, angle PQN is equal to gamma. Therefore, what is cos gamma? Cos gamma is equal to NQ by PQ, which is equal to Z2 minus Z1 by PQ. Similarly, we get cos alpha and cos beta. Cos alpha is equal to X2 minus X1 by PQ and cos beta is equal to Y2 minus Y1 by PQ. Hence, the direction cosines of a line segment joining 2 points P and Q are given as X2 minus X1 by PQ, Y2 minus Y1 by PQ, Z2 minus Z1 by PQ. And what is this PQ? PQ is equal to square root of X2 minus X1 the whole square plus Y2 minus Y1 the whole square plus Z2 minus Z1 the whole square using the distance formula. Here, one more thing we have to note is that X2 minus X1, Y2 minus Y1, Z2 minus Z1, these are the direction ratios of the line segment joining P and Q with the coordinates X1, Y1, Z1 and X2, Y2, Z2. Let us discuss some examples to understand the concept more clearly. Find the direction cosine of the following line. 3 minus x by minus 1 is equal to 2y minus 1 by 2 is equal to z by 4. Here a line is given. So from this line we can find the direction ratios of the line. When we have the direction ratios, we can easily find the direction cosines also. Let's see the solution. First we can write the general formula of the line. Then we can reframe the given line in the standard form, general form. So after rearrangement, we get it as x minus 3 by 1 is equal to y minus 1 by 2 by 1 is equal to z minus 0 by 4. Comparing with these two equations, we get the direction ratios as a is equal to 1, b equal to 1 and c is equal to 4. Alright. Now we have to find the square root of a square plus b square plus c square. Substituting the value, we get the value was root 18. Now, put these values in the equation of a direction cosine and we get the direction cosine as 1 by root 18. 1 by root 18. The z coordinate will be 4 by root 18. So here comes the next question. Find the direction cosine of the line passing through the 2 points -1, 2, 3 and 2, -3, 5. So we have 2 points over here. x1, y1, z1 and x2, y2, z2. 2 points are given here. Now the direction cosine is x2 minus x1 by pq, y2 minus y1 by pq, z2 minus z1 by pq. So first we have to find the denominator, that is pq. Now to find pq, we have to take the square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Substituting the values, we get pq as root 38. So also from these 2 points, we can find x2 minus x1 as 3, y2 minus y1 will be -3 minus 2 will be -5 and z2 minus z1, that is 5 minus 3, you get it as 2. Now finally, the direction cosines are 3 by root 38 minus 5 by root 38 and 2 by root 38. This is the direction cosine of the line. So we know the direction cosines and direction ratios of a vector. So in this section, we have learned about direction cosines and direction ratios of the line. If we are given only the direction ratios, we can easily find the direction cosines. And if we are given 2 points of a line, then also we can find the direction cosines. And this is what we have covered in this video. Now, relating to this, an in-depth analysis of lines will be taken and this will be done in the upcoming section. Now, it's time for a quick recap.
Manorama Horizon. Learning made simple.